Welcome back to RamZland. Today I want to show you my nitric acid fountain. Check this out.
To create our fountain, we'll use one 500 milliliter filter flask with 400 milliliters of distilled water, a glass pipe with adjoining stoppers, a copper wire, of course 16 molar nitric acid, and an empty 500 milliliter Erlenmeyer flask. The first step is to wrap your copper wire around the neck of the glass pipe that's leading up to the fountain. So you want to keep this really close to the rubber stopper, and this will lead to the flask that will have your nitric acid in it. And keep it right at the base of the stopper like that. Next, add 50 milliliters of 16 molar concentrated nitric acid to your 500 milliliter Erlenmeyer flask. Now you're ready to take the end of your glass tube that has the copper wire wrapped around it and fasten it to your 500 milliliter flask that has the nitric acid at the bottom. And you're going to invert this over your glass filter flask.
So when we invert the flask over the water, the nitric acid will come down and come in contact with that copper wire, creating a single displacement redox reaction that creates the products copper nitrate, which is kind of a blue solution, and of course nitrogen dioxide gas. That's the brown gas that you'll see billowing up in the top flask. But when the reaction slows down and the temperature cools, then those air molecules will start to contract and create a vacuum. And the atmospheric pressure outside the lower flask will force water up into the top flask like a fountain. And you'll see a great color change as that copper nitrate turns blue in the top flask. Check this out. Here's the balanced equation for this awesome single displacement redox reaction. We start with reactants copper and nitric acid. We have 1 mole of copper, that's Cu, and we have 4 moles of nitric acid, that's the 4HNO3. When those combine, they create the products copper nitrate, nitrogen dioxide gas, and water. We have 1 mole of copper nitrate, that's the CuNO3 We have 2 moles of nitrogen dioxide gas, that's the 2NO2, and we have 2 moles of water, that's the 2H2O. This is also a reduction oxidation reaction, as the copper is being oxidized because it's losing electrons, whereas the nitrogen in the nitric acid is gaining electrons as it's reduced. I hope you enjoyed today's edition of RamZland, and I'll see you next time. If you enjoyed this presentation, be sure to remember to like and subscribe.